Welcome to the PEAKS 12 Data Dependent Acquisition video tutorial. In this video, I will explain how the DDA database search works in PEAKS, how to set up the workflow, and how to view the results. The database search starts with feature detection at the MS1 level and data refinement at the MS2 level, which eventually allows for association between the MS1 features and their corresponding MS2 peptide spectrum matches. The DDA database search in PEAKS is Denovo-assisted. First, all MS2 spectra are de novo sequenced. The de novo sequencing results are used to help create a short list of proteins in the database to search. After the database search is complete, the similarity between each peptide spectrum match and its de novo sequence, among other factors, are used to score the quality of the peptide spectrum match. Deep learning-based predictions of retention time, fragmentation, and ion mobility, if applicable, are used to rescore the database matches as well. At this point, the user can choose whether to perform searches for additional PTMs or mutations. These options will be discussed in detail in a different video. Now, let's go into PEAKS to see how to set up the workflow. Once you have opened PEAKS, click on this button to create a new project. Name your project and choose its location. Click Add to add your raw data files. As PEAKS is a vendor-neutral software, there is no need to convert the data files before loading them into PEAKS. Click on this button to create a new sample for each file. You can set the enzyme, instrument type, fragmentation type, and acquisition type for each sample. At this point, you can click Finish to load in your samples into PEAKS, or you can continue with the workflow selection. On the workflow selection screen, choose the workflow that you wish to perform. For this tutorial, we'll be choosing PEAKS DB In-Depth Denovo-assisted Search. Next, click on Data Refine. Here you'll be presented with the Data Refine options. We recommend, unless you have already pre-processed data, that you leave these checked as the default. Click on Filter Features if you want to filter out certain M/Z values, retention time range, charge, or abundance. Click on DB Search. This page is the one where you set the majority of your database search parameters. At the top, you'll see settings for precursor mass and fragment ion mass error tolerance. These will be set for you depending on the instrument type you select, but you can change them to any value you want. Under the enzyme parameters, you can either choose to have the enzyme be specified by each sample, which will just use what you chose in the project creation, or you can override the enzyme with one of these. For digest mode, if specific digestion is set, PEAKS will obey the specified enzyme's digestion rules. If semi-specific is set, PEAKS will allow for unspecific cleavage at one end of the peptide. You can also set the maximum number of missed cleavages. Next are the PTM settings. Click on Set PTM to select fixed and variable PTMs. PEAKS has quite a few built-in PTMs, but you can also use your own customized PTMs. Here you can set the maximum allowed variable PTM per peptide. Then you'll select the database. Click on New to configure a new database. Browse to the FASTA file on your computer of the database that you want to use. Give your database a name, and you can also choose its FASTA format. Default ones are UniProt and NCBI, but there's also other parsing rules as well if you want to customize your own. You can choose to validate the database to make sure there's no invalid content. When you're finished, click on Add Update to configure the database. Now your database should be available in the drop-down menu. You can also select the taxonomy for your database. For example, if you have the entire UniPro database and you want to narrow it down for a particular species, you can set that here. You can also set a contaminant database and the peptide length that you want to search for. Check Deep Learning Boost to allow peaks to use predicted retention times, fragmentation patterns, and ion mobility patterns, if your data has ion mobility, to rescore the peptides. You can turn off Deep Learning Boost if you don't want that rescoring. Next are the optional PTM and spider searches. Since we'll be going over these in a different video, I'm going to leave them unchecked for this example. Click on QC. This will bring you to the optional quality control step. Checking this will allow you to view different attributes about your data to assess data quality. I'm going to leave it unchecked for this example. Click on Report. On this page, you'll set your quality filters. At the PSM peptide level, you can choose to filter by either a -10 log P score cutoff that you specify yourself, or a PSM or peptide level FDR. Peaks calculates FDR using a decoy fusion method. You can also set the confident amino acid threshold. As well, you can set either a -10 log P or protein group FDR at the protein level. You can also specify how many unique peptides are required for a protein to be reported. Finally, you can choose the minimum de novo score required for a peptide to be reported in the de novo only tab of the database search result. Choosing de novo only tag sharing will allow de novo peptides that are partially matched to a database sequence to be associated with a protein. You can choose the minimum number of amino acids required for a de novo tag to be reported. Choose de novo only fully matched to only allow reporting of de novo peptides associated with proteins if they're fully matched to the protein sequence. Check Save Workflow to save your workflow parameters to be used in a future search. You can name your analysis and choose whether you want to perform a batch submission. If you perform a batch submission, that's going to create a separate analysis for each sample rather than have all the samples be analyzed and reported in one result. You can also choose to export every possible export that Peaks can generate for this analysis, but you can also export this later. Click on Finish to start the analysis. Now let's look at an example result. This tutorial is meant to provide a general overview of how to view the results. For detailed information about each aspect of the result page, you can see the relevant section in your user manual. This can be found in your Peaks Studio installation folder. In the drop-down menu, double-click on each analysis step to see the result. Let's look at de novo first. This contains the de novo sequencing results for all the spectra. On the summary page, you will see statistics for the number of peptide spectra matches per score cutoff. You can also change the minimum score cutoff for the table in the next tab. The de novo tab will show, per scan, the peptide sequence and information in the table, as well as an annotated MS2 spectrum, an LCMS snapshot, and a precursor profile. The color-coded ion match table shows which ions were identified in your spectrum. You can also click on Survey to see the corresponding MS1 spectrum. Click this drop-down menu up here to change to a different sample. The Feature tab contains very similar information to the De Novo tab, except the results here are organized by feature rather than by scan. MS2 scans which are associated with the same feature are grouped together. Now let's open the database search result. The result will open to the summary page where you'll see various statistics about your analysis. At the top, there are options to change the -10 log P cutoff or FDR at the protein level. You can use the Modify Analysis button to change FDR settings at the PSM or peptide level without rerunning the entire analysis. You can also change score cutoffs for PTM confidence up here. On the rest of the summary page, there is an FDR curve, score distribution figures, a statistics table, sample overlap, distribution of features, filter parameters and statistics, a PTM profile chart, precursor mass error distribution, missed cleavage statistics, and a summary of your search parameters. The Proteins tab displays the proteins identified in the database search which have passed the filters. Click on a protein in the table to see the supporting peptide coverage. The peptide coverage and de novo tags can also be viewed in a list form. The Peptides tab will show each identified peptide in the table with its score and other information, including the area of the peptide features per sample. The MS2 scan will be shown below, with the feature with the highest scoring PSM being shown by default. A mirror plot showing the experimental versus the predicted spectrum is shown. Click this button to change to an annotated spectrum. The Modified Peptides tab shows modified-unmodified pairs together in the table and in a mirror plot. A confident modification will be shown in green, and an unconfident modification will be shown in red. The De Novo Only tab lists scans and peptides by sample which were not identified in the database search or were identified but did not pass the filters. Finally, the Features tab lists the identification by feature ID and shows whether or not there is a database or a de novo match. Click on the Export tab to choose which results you want to export. Results will be arranged by each analysis step. For example, you will get separate options for de novo and database search results. CSV files will give you tables similar to the ones you saw in the Result tabs. Check off the exports you would like, browse to choose the folder you want to save everything into, and click on Export. We hope you enjoyed this tutorial. For more information, please visit our website, bioinfor.com. Thank you for listening.